Okay, everybody, this is your stoichiometry video review. And so I'm going to go through these problems, and hopefully this will help explain a few things for you if you had trouble. Okay, the question is, how many grams of aluminum chloride are produced if 13.5 grams of aluminum hydroxide react with excess hydrochloric acid? First of all, when this says this right here, we don't care. Okay, so let's break it down. How many grams of aluminum chloride? That's the question they're asking. That's going to be a B. 13.5 grams of aluminum hydroxide. That's going to be A. So let's set it up. Well, first I'll tell you before I do that. Aluminum chloride, there's B right there. Aluminum hydroxide is A right there. Let's set it up. Well, that's kind of a curvy line. Anyway, start with 13.5 grams of aluminum hydroxide. Okay. And on your flow chart, the next thing you do to get to number 2 tells you to put 1 mole of that over its molar mass, which I'm putting at 78.03, okay, grams. Next is the mole ratio. Moles of B over moles of A. AlCl3 is the B, that's 1 mole. And therefore we have A being aluminum hydroxide, that's 1 mole. Okay, last step. The mass of the molar mass of aluminum chloride over 1 mole of it, and that molar mass is 133.35 if you calculated it right, over 1 mole. So doing the math, let's see here. We get I got 23.1 grams of AlCl3. Okay, that's a mass-to-mass problem. Number 2, calculate the number of moles of water produced when 4.4 moles of copper nitrate are formed in the reaction. So we want to calculate the number of moles of water produced. Okay, well, that's not too hard. This is a mole-to-mole problem. We started with this right here, and we got to calculate the number of moles of water. All right, so let's do that. Set it up. Start with 4.4 moles of Cu NO3 2, and we're going to put that. The next thing we got to do. That's starting at number 2 on the flow chart. So that means we got to go straight to number 3. And the only thing you've got to do with this, since it's a mole to mole problem, is do a mole ratio conversion, and that means we have 4 moles of water, because that's our B. Oops, let me erase that and make that nice. 4 moles of water and over 3 moles of CuNO3 because of that 3 right there. Oops, that's the wrong 3. This is the right 3 right there, and this is the right 4 right there, and there's your mole ratio. So now you calculate, I got 5.9 moles. I don't care if you rounded it to a whole number, guys. I just don't care. I just want to make sure that you know the process. That's the most important thing, because on your test tomorrow, it's multiple choice, so you'll be able to identify the right answer. How many grams of hydrogen gas H2, that's B, are produced from 3.78 moles of potassium? That's A. Reacted with excess water? We don't care. So now, A is potassium, right there. Hydrogen gas is B, right there. And so now, let's set up a problem. Okay, so this is a mole to mass equation. So you'll start at number 2, and you'll end up at number 4. So let's go. 3.78 moles of potassium, and now we go straight into our mole ratio. So the 2 goes down here because that's our A, 2 moles of K, and our A is hydrogen right here, or B is a hydrogen. It's going to be 1 mole of hydrogen here. And now to do the molar mass conversion over 1 mole, so 1 mole of H2 here, and 2.02, because there are 2 atoms of that, grams of H2. Solving for that, I got 3.8 grams. Okay, there's that. Number 4. If 32.6 grams of nitrogen reacts with hydrogen, how much ammonia will be produced? nitrogen, okay, reacts with hydrogen. We don't care about that. That's okay. That's why I'm telling you to get rid of some of the information. How much ammonia will be produced? That's going to be your B. This is going to be your A. So that's A. That's B right there. And so let's set up a problem. This problem here is a mass to mass. All right, mass to mass. So let's set it up. 32.6 grams of nitrogen. Okay, that's number one on the flow chart. Now we got to go to number two, and it tells us to put 1 mole of that over its molar mass, which is 28, because there's two N's right there, 28 grams, right? Now the mole ratio comes in. B over A. That's 2 moles because of the NH3, and then we have 1 mole for the N2, put NH3 right here. And then the last step between number 3 and 4 is the molar mass of NH3 over 1 mole of NH3. The molar mass, I calculated 17.03 grams over 1 mole of it. There's a setup. I calculate, should get around 38.9 grams. I think that's what it should be. Hopefully I did that right. But it is the right setup. Okay, number 5. Calculate the mass of zinc, that's going to be B, when 33.8 grams of aluminum reacts. That's going to be A. So there's A, there's B. Mass to mass problem once again. So here we go. All right, got a long line going. 33.8 grams of aluminum. That's number 1 in the flow chart. Now between number 1 and number 2, 1 mole of that over its mass, or molar mass, grams of aluminum. Between 2 and 3, the molar mass of B, the moles of B over the moles of A, that's 3 moles of zinc over 2 moles of aluminum. So aluminum is our A. Last step between 3 and 4 is the mass of the zinc. I have it 65.5 grams over 1 mole of zinc. That's the right setup. Calculating it out, I got 123 grams when it's all rounded up right. I believe that's right. If I'm wrong, somebody let me know. But that's the right setup. Okay, number 6. If 14 grams of aluminum hydroxide is present, that's your A. Determine the theoretical yield of aluminum chloride. Okay, we said today that theoretical yield is a mass to mass Stoich problem, and AlOH3 is our A, AlCl3, our aluminum chloride, is going to be our B. Set it up. Start off with our A, 14.0 grams of AlOH3. And that means the next step is going to be the mass of that, 70. I'm going to round to 78 this time because I feel like it. AlOH3 and 1 mole of that. AlOH3. And now, that gets us to step 2. Now let's go to step 3, mole ratio. That means B over A, so 1 mole of B over 1 mole of A. And now finally, the molar mass of aluminum chloride over 1 mole of it. So the molar mass being 133.35 grams over 1 mole. There's this perfect setup. I calculate 23.9 grams of AlCl3. That is your theoretical yield. Okay? Theoretical yield. Right? We're going to use that number for problem 7. Okay? And so here we go. If the actual yield of aluminum chloride in question 6 from the tablet is 22.0 grams, what is the percent yield? Okay, percent yield equals yield actual yield over theoretical yield times 100. And so that's going to be 22.0 divided by 23.9 from problem number 6. Grams for both of them. And when you multiply that by 100, divide that out and multiply that by 100, you get 92.1% or so. That is your percent yield equation. Okay? Number 8. What is the molar mass of C6H12O6? Well, that's C6. That's carbon 6 times. That's going to be a total of 72.06. Use your periodic table, guys. H 12 times. Okay? That's going to be 12.12. O6, or oxygen 6 times, is going to be 96. Adds up to 180.18. And that is our molar mass of glucose. Okay? 9. Molar mass of iron 3 oxide. All right, well, here we go. So we have iron at 55. Oh, my page is mixed up here. Iron at Fe equals 55.85 times 2, which is going to equal 111.7. Then we have oxygen times 3, and that's going to be 48. Oops. That's just messy, isn't it? That's going to be 48, okay? Well, I'll say it this way first of all. That's going to be 16 times 3, which equals 48. And you add those two together, and you get a mass of 159.7 grams per mole. Okay? There you go. You got to use the periodic table. Number 10. Mole ratio between lithium and bromine. Lithium comes first, bromine comes second. So we're going to have our colon here. We said lithium comes first, so we look at lithium, we see a 2. Well, I'll put a 2 there. Bromine comes second. There's a 1 in front of it. There's nothing there. Ratio is 2 to 1. Mole ratio between zinc and aluminum. Zinc comes first in the problem, so let's find zinc. Here it is. Put a colon out there. There's a 3 in front of it. Put a 3. Aluminum becomes second in the problem, and that's going to be a 2, so put a 2 there. Ratio of 3 to 2. All right, getting closer, guys. Okay, the reactant that runs out first, okay, it limits what can be produced. That's called the limiting reactant. Okay, it limits what you can produce. Therefore, the reactant that is left over, okay, that means you have excess. That is the excess reactant. Okay? All right. Got a few to go, or a couple to go, and we are done. Reaction was predicted to produce 10.55 grams of carbon dioxide. In reality, it produced only 9.87 grams of CO2. What is the percent yield? Okay. So in reality, that's going to be your actual. Predicted is going to be your theoretical. And remember, the smaller number goes on top. The bigger number goes on the bottom. So your percent yield equals actual over theoretical. And that's going to be 9.78 divided by 10.55 and multiply by 100. And you get a number that looks like 92.7%. Okay. Last one. Wow, that's big. All right. So, for an experiment, you calculate that 31.9 grams of lithium bromide should be produced. When you weigh the product, you only have 27.8 grams. What is percent yield? Well, when you weigh the product, that's going to be your actual yield. Okay, 27.8 grams. You calculate, stoichiometry-wise, 31.9 grams of it. It should be produced. Okay, that's what you think it should be there. You're trying to reach that number. Percent yield equals actual over theoretical, and that means 10 27.8 divided by 31.9, and we then multiply that by 100. You should end up with 87.1% or so. Okay? Okay. That is your review. That's how all the problems should be set up. Make sure you're labeling your A and your B on your test. Make sure you're boxing your, box your answers, guys. And be careful when you are calculating, using your calculator. You might want to clear it out before you start. All right. If you have any questions, you can get a hold of me. Have a good night. See you tomorrow.